Okay, guys, thank you for joining to this awesome talk. We take a look very quick, or not, could be not, about observability. Also, we focus it on Kubernetes. That is our focus for this talk, and we take a look more deeper about how we can check and instrument and focus it observability in our applications. So please join to this awesome journey for today. That is me, that is Jhonnatan Gill, and let me change the landscape here. So we can start here. At this part, we talk about for this couple of this little presentation about observability, and this is me, Jhonnatan Gill Chaves. But let me move here. So who is Jhonnatan? Who is Johnny Pong? Who is Jhonnatan24? Just a human that loves share knowledge about instrumentation, about Linux, about ecosystem, about cloud, about DevOps, about SRE, about something that I learned, I want, and I love share that. That is my social network on GitHub, on YouTube, and also for Twitter of X. And I love this little quote. Life is really simple, but we insist on making it complicated. That is really true, because when we start for this journey on IT journey, we have a lot of challenges every day. So that is our preposition, I think. This talk, observability in Kubernetes. Also, we talk in deep about metrics, logs, and traces with open source tools. That is the best part. The open source tools for our companies and also the every part of the implementation here. That is of content for today. We talk about for biggest scope for introduction, observability, what is cncf, what kind of tools we can check for open source tools, what we have challenge here using observability on Kubernetes, and also we take a look in a little demo here. So start with the introduction side. We need to take a look very quick about the Kubernetes architecture right at this moment. So we have at this part the information about how the Kubernetes internally works, because we need to take a look here, the control plane, and also the worker node that is related here. And also if we deploy this cluster using some cloud providers, we need to communicate our clusters using this cloud provider. And also we have a little here also these components. So we need to take a look more in depth about the internal worker nodes components that is related here. We have internal for the node, we have our container runtime, Docker, container D, or something like that. That is part of the node, not for the control plane. Control plane must focus it for the brain behind of, especially for etcd and schedule part. That is pretty awesome job here, because using the reconciliation process, they mention how we can deploy our workloads inside of the cluster of Kubernetes. So this part of kubelet and kubeproxy internal for Kubernetes, the kubelet is how we can respond all requests from the control plane side, and also using the kubeproxy for how we can communicate one process for another. I means how we can communicate one pod for another pod, or one service for another service. That is part of the kubelet proxy internal deployed here. The another scope here are related for the pod. The pod, that is the minimal part that we can check inside of Kubernetes, but is the most important, I think, because that is related for our application, that is related for our daemon set that we can generate it using depends of our needs, current CRDs behind of Kubernetes. So we need to take a look for this. That is at the end of the day, the workload that was executed and contains our applications for service all our customers. So we have here one container or couple more than one container inside here. We have one part for the network, another part for the volume that will be you attach for your pod. Depends for your needs that you need to deploy inside of Kubernetes. Also, we have at this moment Kubernetes add-ons like a DNS, like metric server that you add it to the node, and you can expose and communicate and generate this relation between another tools. And another part, we have daemons, jobs, and another objects inside of Kubernetes that will be deployed on inside of the worked node, but depends exactly for what kind of object you implemented for your cluster, right? So that is a big scope about the architecture for Kubernetes. We have here a lot of challenge if you try to observe what happened in your cluster, what happened with your application. The focus for today and this talk is focused for pod that is related for our application, right? So we need to take a look very quick about what is observability. We have here observability that is related for the property for the system, and we can take an actionable insight for our application that allow to us to understand the system. That is the current state, depends for the external inputs and how to these inputs modify the behavior internal for our application, right? So I take this definition from the glossary that is related for cncf, that we need to take a look more in deep about in this talk. So at this part, we define the oily and white. The oily and white is related for O, for this O, and the 11 characters here, and the Y, that is the end. Very fancy, very similar for the Kubernetes scope, that is for KOS. So we have the same correlation here. Please explore if you can take a look from some article, something like that. You find observability, you find the oil and white at the same part. That is very common internally. It depends on your teams or depends on your advantage that you have internally for all your application that you have currently, right? So move for the next. We start in deep about the observability golden triangle. That is very important for us, especially because at this part we define what kind of information we can get from the every application. We have from one part, once defined for logs, that is unstructured data that the application start to execute. When we execute one application, generate a lot of data behind of the implementation framework, the implementation languages. So you have the name for the application, could be or something like that, and you can store and get that information at the end of the day. That is one part. The second part is the metrics that is related for quantitative information around the components that support your application. What components? The CPU, the memory, and also the disk that you attach it for this case for the pod. And also we can take a look about the traces. That is could be the most challenge here, because we have one request that comes from our application and how we can measure that request jump to another application. How we can take a look for that, and we can see what happened with this request and what happened with the another response for that other system or the implementation, and also the communication side that we need to take a look at how we can adopt this challenge for us, and how we can move this challenge also for our teams internally for take more deep about information from our systems, right? But we need to take a look for these three information side for our applications. So why we need observability? That is an awesome part, because we take a look very quick for our application. There is our customers at this side. We have our cloud providers, something like that, or could be in bare metal. And this request comes to our firewall this request jump to the load balancer, this request jump to the application, the front application or backend application, I don't know. And this application queries some data to the database side and also get information for our archive. So that is a normal architecture that you could deploy for your support or your system at this side. And also we have here one challenge, because we have this spider guy, right? We have this application and we generate this application and split this application using the microservices or services or nano services behind of, depends of the architectural definition that you have internally. So you have this challenge, right? Because we are the Spidey guy. But what happened one day to this Spidey guy happens? The database wrong, database fail, the firewall fail, the application fail, the archive fail, our cloud provider fail, or could be load balancer fail. How do we can check if these components work well or not? We need eyes inside of our infrastructure, of our inside of our application also, because if we don't take a look for these components inside of our application, that it's very huge problem here. Identify exactly the root cause here. That is one part that we need to take about observability, because we don't have these eyes inside of application. We don't have these eyes normally for the infrastructure side. We need generate this eyes for our little spider guy. So we need to pray for this little guy, because at the end of the day, this is the man that we need to take a look for what happened internally for this application, right? So we move from the Spidey guy to instrumentation. Why? Because we need to use a couple of definitions behind of that we talk about. For one part, for the pod, we need to talk for one part for these little architecture definitions. But when we move for the instrumentation, we take one part from the Wikipedia, and this Wikipedia mentions to us, hey, we define the instrumentation as part for the physical drives, and you most could be for the a customer's side. How do we can get this measure internally for your granary or something like that, or your farm? How do we can explore these physical devices for obtain information about the environment, right? If the environment is well or not, or could be wrong with the deploying all these focused, all these data that you can be collected from your side on also what happened internally for the farm. So we need to take a look very quick and very in a same way for observability, because we need to instrument our application. We need to generate this methodology, automation for our application also. How do we define exactly the physical, or in our case, the software devices for take a look for this instrumentation? We need to define how do we can instrument the application, how do we can collect this information about the logs, traces, and metrics for every part of our application. So we can define how do we can take a look for this application, or how do we can obtain this information, and also how do we can send that information for a correlation side, and also how we can store as that information also. At this point, we need to take a look for this, the cncf. The cncf is related for the Cloud Native Computing Foundation, that is behind of one of the biggest projects here. That is once for Kubernetes. The second one is OpenTelemetry. That is pretty huge projects behind of that the community support for the community, and also deploy and support to the community. That it's very nice ecosystem, because when we talk about the community, we talk for one part of the biggest smart guys behind of. That is the biggest challenge here, and also that is the biggest impact for the community from the community. So that is that as part of the CNCF, the behind of are the Linux Foundation. The Linux Foundation could be, could be done. That is the Linux behind of the open source operation system that you could be implemented for your internal application, or could be your Docker set application or something like that. So now in that on mine, we have at this point we have the landscape. That is the address here. You can explore also, and we have one chapter here related for observability and analysis. And also when we start to explore that, we have a lot of tools that they from the pay side also, and also the open source side. We have at this moment 90 tools here focused for monitoring. We have at this 21 tools focused for logging, and we have at this point 18 tools for tracing. So exists two more ecosystems here that I don't have in this presentation, but if you explore the landscape, you can check. That's one's for chaos engineering, and also the another one is for the optimization part. So when we start for observability, we can enable a lot of components behind of the application, a lot of components behind of our structure, and also for our companies, and how we can move very quick for another practice internal for our companies. That is pretty nice, because when you start seeing what happened internally for your company, you can start to move and start to generate more focus for another part that you could be done. Take a look in deep for some cases, right? So with this part, we need to take a look very quick for about these open source tools. I recommend for instrumentation using OpenTelemetry. You can use another SDK, depends for your cloud provider. Also, you added the SDK libraries, and you can deploy these libraries and implement, and you define with the development team how we can start this journey for the instrumentation side. But I recommend that is very quick with OpenTelemetry, because with OpenTelemetry you have the two possibilities for instrument your application: the auto instrumentation, that is part for adding just one line, or could be in Kubernetes adding the sidecar pattern, and also this take a look about the information from your application deployed, and take this information from your application and start tracing these metrics inside for logs, traces, and metrics. That is one part. The second part is related for manual instrumentation. The manual instrumentation are related for, hey, I need to take a look how we can collect that information about the log, about traces or metrics, and I split this little side. Could be this is more difficult, but depends exactly for your maturity appliance for observability internal for your teams, right? But I recommend exactly OpenTelemetry is a nice tool, a nice framework. Sorry. Also for collect logs, I recommend FileLog, that is supported by OpenTelemetry, and also for traces, Jaeger, and for collect these metrics, I recommend Prometheus. So that is the path that comes from observability. We instrument the application, the instrument applies to the application, then the application generates logs, the application generates traces, and application generates metrics, and expose that metrics, the traces and logs from one side using OpenTelemetry framework, and you can collect this information and also see and take a look inside of Grafana. For one side, we need to how we can store the logs, how we can store the traces, and what is the life cycle that you have internally for this quantity of traces or times. Could be 1 month or 6 months or 1 year or something like that, depends on the object for the company side. And also you can take a look inside of on the top of these collected metrics, you can drop in using Grafana, right? So what happened with observability side on Kubernetes? We have these two approaches internally for Kubernetes side. We have for one side OpenTelemetry that I recommend, and also exists another part that is related for eBPF. But eBPF is more focused for implementation and efficiency, and if you want take a look more in deep, you can check this article and also read another resources. I check this article and I see that it's pretty awesome how they explain the differences between from one side and another side. Yeah, but I mean, and I appreciate exactly this part of OpenTelemetry that is very easy to use, and also all the compatibility that currently have for all languages that you call implemented your microservices. If you want to take a look for OpenTelemetry or eBPF, please take a look, and please feel free to doing that and also start this journey for observability side. So that is the best part for our side. That is the demo side, right? We have here the architecture behind of. Let me out for the presentation mode, and also we can take a look very quick for this demo for OpenTelemetry. We can access here. Exactly, OpenTelemetry define how you can implement OpenTelemetry, and this part of the architecture side add to you exactly this kind of frameworks for that side, and also this is the architecture deployed for this demo. We have on one side these microservices deployed here. This microservice was wrote on .NET, C++, Erlang, Golang, Java, JavaScript, Kotlin, PHP, Python, Ruby, Rust, and TypeScript. That is the common languages in on the current scope for we have. And also when we have this microservice here, we define exactly how to the data comes and how to the data flow internally for our application, right? When we export and we try to call it these metrics, what happened internally? We need to take a look for Prometheus from one side that is related for the EPM side, exactly for CPU, memory, and disk, right? And then other side that is related for JK, that is for traces. If you want to add the part of the log, please go ahead and take a look for this instrumentation, how you can store the log and how you can define this flow for the log side. So from Prometheus, you collect this information for the microserver side. These are part for the OpenTelemetry collector, that is the configuration internally for your application, and you explore this part that is how you can receive that information, how you can process that information, and how you can export that information from the OpenTelemetry configuration. That is pretty awesome here, because if you want to generate, could be a lift and shift, and I don't like Prometheus, I use another tool. I don't like Jaeger, I want to use another tool. You can remove from here and you added your flow, and you can move very quick for start using another tool. That it's pretty awesome, because you don't need exactly change more internally for your teams or your development team. You just need change the configuration side. That it's pretty awesome, because at the end of the day, you remove this responsibility for the development team, and you add this responsibility for the IT guy, but you need to know more in depth what happened internally for your traces, and how you can call it that traces for every signals that you have internally for your system, right? So that is internally for Prometheus. Prometheus receive that information using this URL, and also this information will be stored on the Prometheus transactional database. And at the end of the day, when the data was stored, the Prometheus reflect that spark for export that metrics, and also you can see that metrics using Grafana. That is part for Prometheus, and is the same way for Jaeger. Jaeger comes here using the gRPC protocol and comes that tracing here. Jaeger store that information and Jaeger export that information that will be consumed from Grafana side. That it's pretty awesome because at the end of the day you have this site that you can take a look for like a pipeline, something like that internally for OpenTelemetry configuration side. And you can drop here one tool that is Prometheus, and you drop here another tool that is called Jaeger. And also you can use Grafana internally at this point for explore your metrics and also generate this awesome dashboard that you can share with your IT guys, or could be for more than for your CTO or CEO guys. And also when you drive to this dashboard, you need to take a look what kind of the customer end user need to see this dashboard. There is another journey, but you need to take a look internally for that, right? So that part for the architecture side, and also that is related for the ingest flow or the telemetry data flow or the signals flow for store that information. So we can take a look very quick this demo. This demo actually is currently on my GitHub, and also if you want to explore and generate this information also and explore that demo internally for you, are pretty well. Currently I deploy all my infrastructure using AWS. So let me move here very quick to our demo site. So previously I don't run exactly the part of the cluster generation. Let me start the cluster. So at this side we need to take a look here. EKS create cluster here and also drop here. At this point we start to create the cluster site. So let us wait for create this cluster. Okay, so we take a look for this cluster recently created, that was created from using the EKS CLI version from AWS generated. We send here the cluster information related for version that is 1.27, and the name of this cluster will be Conf42 QA native. So if we take a look here very quick for Elastic Kubernetes service, that is internal for Kubernetes for AWS on exactly the region USA East 2, we have also the possibility to check what kind of component was deployed on this command. This command deployed the whole cluster that we talked internally on previous slides, that is related for the control plane and workers node side, and also another capabilities that AWS needs to manage this cluster, because when we deploy using the EKS CTL or using the EKS provisioning way, we deliver some responsibilities for AWS. That is pretty awesome, because when you define a cluster, you have to define exactly what kind of part of the cluster you generate here. So let me move because I select the wrong part here. So move very quick to EKS again, Elastic Kubernetes services, and also take a look for the cluster create. At this point, you have the possibility to check what happened with your cluster. We just have the empty cluster because we don't drop here any kind of components at the moment. So let us check. Meanwhile, kubectl get pods print A. When we send this information, we connect from the API side and request all pods from this API, and with this option -a in uppercase, we request that was focused for all namespaces internal of Kubernetes, right? So we have here the part of the Kubernetes side, the Kubernetes deployed on AWS, and also you can see here the commands and the all pods internally deployed on Kubernetes side, right? That is our the current deployed. Look at current service API. That is a timeout here. That it's very uncommon part, but could be you don't have to see that. We create this cluster 20 minutes ago, and also if we can take a look for the compute here, we have these worker nodes that is part of the Kubernetes side, exactly for the worker nodes side when they supported the deployed here, all pods that we need to deploy it. So we continue here with our cluster definition. We can use this alias that is very helpful for you if you want to send more quick comments inside of Kubernetes. You just send kubectl get pods -a, and that's it. And it's more quick for generate and send that request for the API side. Okay, we need to take a look for another tool that is called Helm. Helm is a package manager internal of Kubernetes, and also we start using this tool that is part for the components deployed, and that's it. They take a look from the pod side and end, and we pass here the command. With this command, we added the repo. With this command here, the repo call it OpenTelemetry, and this take from this Helm chart that are stored on GitHub side. OpenTelemetry already exists, yeah, because we added previously. Helm repo update, because in some cases you need to update the reference internally on your system, that is on your local environment, not currently yet for the cluster side. Just update this repository on your side. So that is the important command. One is the important command here, because we added this configuration side. Because if you sense the first one, here you have our own definition for Helm file, because it depends exactly for the version for Kubernetes also. And we deploy the Kubernetes using the API deployed on use Kubernetes side for 1.27. So at this site, we install a package management for Kubernetes that we will call it MyHotel demo. And also we use the OpenTelemetry demo. So we have here the OpenTelemetry side, and we use from this package management the OpenTelemetry demo using the version exactly 0.21.1. That is the components that will be deployed on inside of the Kubernetes side. So we need to wait here a little time, because they need to download this package for this version and start deploying all packages inside of Kubernetes. What kind of packages? We talk about the pods, we talk about the services. We need to deploy a lot of components behind of the part that as part for this architecture that was defined for the OpenTelemetry side, right? Also, that is very quick if you want to install your applications, because you install download and install site that it's very awesome for your application and start your journey to observability using OpenTelemetry side. That it's very quick for start your POC or spikes, depends of the maturity of your teams. So we need to take a little time here. Wait for this appliance internal for the Kubernetes side. When these components are already deployed, we can send this and prepare this command here, and also these references internally for the Kubernetes side. Okay, and the installation side, and we can open using the port forward configuration side here, and we drive this port forwarding for the service internally, for the service called myhotel demo, and we generate this port forward from 8080 locally, and they take from the internal side for 8082. So we can send this for the kubectl port forward side, and this granted to us access to this information that we return from the Helm installation side. So open the first part that is related for the one deployed here. That is for the web store. That is the application that we deployed using the architecture here. And also we need to take a look for Grafana. That is the part that we start to check what happened here. So meanwhile the port forwarding start, we wait also. So that is our application side, and this jump for every request that was returning for our web browser here. That is the part for our application. That is a huge application. When you down, the products start to load, then the requests start to generate also. And when we move to Grafana, we have that part for the one's configuration side. If we move very quick here for not for the configuration, just for the data source, we have here the Jaeger configuration that we mentioned, that is related for the traces, and also for Prometheus, that is related for the disk drive, and this CPU and memory side for our application, right? So we take a look here very quick for the default dashboard that was created on this deployed. So open this for dashboard, and also we can take a look very quick about this dashboard. If you saw that it's very quick, this installation, it's just a couple of minutes for start your journey to observability using Kubernetes side. Also, you can start the journey using other tools, yeah, but could be you need to take a look more in deep about these concepts, and also generate this implementation about in your application side, so that it's that you want to need to take a look internally with your development team, right? So we saw here information related for this service, right? We have the feature flag service, and also we jump for every service here, and these graphics update for that service and what kind of service, and also how to this service was deployed inside of the Kubernetes, right? You can jump and explore all service here, and you can see here what happened with the CPU, what is the recommendation here, the recommendation for memory, the recommendation for count, the error rate, the service latency, what kind of the times what's generated for every service, and from the request to response, the times between of that, and the error rate that is related for the errors that you have internally for your application side. That it's pretty awesome because you have using the traces that comes from OpenTelemetry. You have this dashboard, and also if you added your microservice, you can drop here and identify your service, and you start this journey using your OpenTelemetry instrumentation side that you can enable for that. For that side, we have, for this dashboard, we have information from receivers from the exactly this component that we call it here. Let us move. I close this part. But when we talk about the configuration side, we talk about the one flow here. Let us load again the OpenTelemetry page. Oh, that is here. This auto configuration, right? We have internally deployed on Kubernetes one components on Kubernetes. So we need to take a look what happened with this component, what is the behavior for every request that comes from our application, or for the flow data ingested from Prometheus and also for Jaeger, and what kind of behavior we can check here, right? What is the comms requested for, and what is the response, or what is exported for that. That it's pretty awesome because enable the observability also for your components deployed for that. The another part that is the trace pipeline, that is the complete OpenTelemetry collector data flow that is related for this part, this flow, how do they jump from one side for another side, the collector here, the processor here, the batch here, and the exporter here, and for login are also for OpenTelemetry. That is for the trace pipeline, and this part for the metrics pipeline, right? We have currently obtained that information from one part for the trace, from metrics, and what happened with Prometheus. If we open this view here, we saw the Prometheus collect information for these services. That is what all pods deployed on the current deployed cluster, right? So we have here exactly what happened with these components for this configuration side that is related for this diagram, and that we can take a look here, and also what happened internally for these components. It was accepted or refused, what is the total, what is the batch side, what is the total for this batch, and what happened here for login and also for the OpenTelemetry configuration side. The next is related for the span metrics demo. That is all traces that currently we have from OpenTelemetry side, and also we saw here what happened exactly with these components. What is the jumps? What is exactly the request times? What is the endpoint latency for every component that you currently have? And it's pretty awesome because when you start this journey, you need to identify exactly what kind of components are behind of your application and what kind of these components you need to take a look more in deep for this implementation that you currently have. So that is the exactly configuration for that. If you want to take more in deep about these metrics, you can move very quick here, and also you can run these metrics and you generate the metric. For that case, we use the add request, and you run the query here, and you take a look that information from this. And also you want to take a look what happened with your jumps using for Jaeger, you can, hey, please load this information from the Jaeger side. Run query. No, we need to take a look for this search and generate and select one service here and execute the query, and you start see what happened with the trace internally. And when you select this trace, you have the possibility to show what kind of jumps this request generated. This request generated one request for, let us open here. Okay, open here. This request generate another request for checkout services, for car services, for product service catalog, for currency, for product catalog service again, for currents, and these all jumps that you are currently had with this instrumentation side for your metrics. That it's pretty awesome, I think, because at the end of the day, you could enable this demo for start your journey to observability side. So that is part for the demo side, and also you can take a look and more in deep for your side. And also if you want to deploy a cluster, or could be you have your cluster, you have the possibility to deploy that using your current cluster. You don't need exactly to generate a new cluster also. So that is a brief resume that we talked for today. That is from metrics, loss and traces with open source tools. We have on one side the Kubernetes architecture in a big scope, the observability, what, why, where, and how. The instrumentation side, that is part of the how side. The golden triangle that we need to take a look in deep for with our development team, the CNCF, what is the scope from CNCF, what is the community for the community, and also the open source tools that we take a look for doing and start for this awesome journey to observability using Kubernetes site. So thank you. I appreciate your time. I appreciate if you learn something new, and also if you want to contact me, you can send me a message using GitHub, or could be using YouTube or X or Twitter. Like you mentioned, you have here exactly what kind of reference that you can read also for take more in deep about this research, about this process, about the terminology behind it. So I appreciate your time. See you soon. Thank you.